Let us solve this question. I will read the question. An electron is confined to move in a one-dimensional box. So this is a 1D problem of length 1 Armstrong. So its energy in the first excited state is approximately. So for a energy of a one-dimensional box, we should be familiar with that energy equation, which will be equal to E is equal to n square h square by 8ma square. Now let us see what are the substitutions. N value, it is energy in the first excited state. So first excited state is n is equal to 2. H, we know it is 6.626 into 6.626 into 10 to the power of minus 34, and that unit is, one second, unit is meter square kilogram second inverse. And a value is in Armstrong, 1 Armstrong, which is equal to 10 to the power of minus 10 meters. And it is an electron. So electron mass is 9.3 into 10 to the power of minus 31 kg. So you can substitute these values. And you are asked to determine in the electron volt. You see the options, in all the options it is electron volt. So you should know the relation between charge and the electron volt. So 1 electron volt will be equal to 1.602 into 10 to the power of minus 19 coulombs if the energy we are treating it as a charge. So for 1 electron volt it will be 1 by 1.602. Now let us substitute each one. So this will be energy in electron volt. I am writing in electron volt will be equal to, first let us substitute for n is equal to 2, so that will be 4 into, next is h value 6.626 into 10 to the power of minus 34, the square of that one, divided by 8 into mass of electron is 9.3 into 10 to the power of minus 31 kilogram, and a square is 10 to the power of minus 10, so that will be 10 to the power of minus 20. Now to convert into electron volt, you should divide by it will be into 1.602 into 10 to the power of minus 90. That will be your electron volt. As you know, in CUET examination, calculator is not allowed, so you have to do it by yourself. The easiest way which I used to advise students is, first you write all the exponential part in a separate manner. So 4 into 6.626 into 6.626 divided by 8 into 9.3 into 1.602. Here it will be 10 to the power of minus 34 square divided by 10 to the power of minus 31 into 10 to the power of minus 20 into 10 to the power of minus 90. So you can simplify this part. So 34 into 34, it will be 68. So that will be minus 68. Here there is minus 31. So how much it will come? 31, 20, all are minus 19. So that will be 9 plus 1, 10, 1, 4, 2, 6, 7. So this will be a 10 to the power of minus 70. Minus is, it will be 10 to the power of 2. So it will be 4 into 6.626 into 6.626 divided by 8 into 9.3 into 1.602 into 10 to the power of 2. So 6.6 into 6.6, just we will try a simple method. 6.6 into 6.6 you can take it as 66 into 66 is 36 3, 36 plus 3 39, and again a 396 here. So 6 9 6 15 5 1 10 3 140, it comes around 43.56. And so let us take it as 44. 44 into 4, this 4 44 into 4, 16 1 16 176. So this will be 176 divided by 8 into 9.3 into 1.602. Now you can simplify it again, and the final answer, it will be it will come around 176 by 8. So 9.3 into 1.6, so you can take it as 1.5. So this will be equal into 10 to the power of 2, which will be equal to 176 divided by 8 into 9.3 into 1.5. So it is 9 plus 9 18, 18 sorry 9 plus half of 9, which is 4. So this will come to around 8 into 14, 8 into 14 into 10 to the power of 2. So this will be finally around, yeah, the final answer should be around 150.4 electron volt. So your right option will be option number 1. Please remember, you cannot use calculator in the CUT exam, so you should practice the numerical values.